Hi, my name is Dipinder. I'm a computer scientist and machine learning and AI enthusiast. Recently, I took on the AI residency program with Apziva, and the reason was to get better with machine learning and get more hands-on experience. This is the first project I took on with them, and it's for a logistics company which does on-demand deliveries for their customers. And currently, they're facing several challenges, and they basically want to use this data to figure out what's driving customer satisfaction so they can better target their customers to drive more business. And the data that was provided was fairly small, which was one of the biggest challenges for this project. And over here, basically use pandas to read the data into a data frame. For the data definition, we have our target attribute, which is 0 and 1, 0 being unhappy, 1 being happy customers. X1 is my order was delivered on time. X2 is contents of my order was as expected. X3, I ordered everything I wanted to order. X4, I paid a good price for my order. X5, I'm satisfied with my courier. X6, the app makes ordering easy for me. Upon doing the exploratory data analysis, you see that there are slightly more happy customers than unhappy customers, not by a big margin. So the data is fairly close for happy and unhappy customers. For happy customers, the biggest driving attributes are they tend to get their orders on time, they feel they got good value for the product, are satisfied with the courier, and find the app easy to use. For unhappy customers, the main driving attributes are they're more likely to report late deliveries, feel the price wasn't good, be dissatisfied with the courier, and struggle with the app. It kind of makes sense in terms of the attributes linked to being unhappy. And the attribute order accuracy and completeness don't show a strong difference between happy and unhappy customers, but this is exploratory stage at this point. From the correlation matrix, we noticed that on-time delivery, good courier service, and app usability are most positively linked to customer happiness. Order accuracy has very little effect. Overall, no strong correlation between any two variables, which means the variables are unique and not redundant. So we don't have to remove any variables at this stage. Here are the charts based on what I just explained. As we can see that unhappy customers and happy customers, the difference is not by much. Over here we see X1, which is my order was delivered on time. We see that a lot more happy customers, rating it 5. And then X2 being my contents were as expected. Fairly neutral, but a lot more happy customers in the middle. And X3 is I ordered everything I wanted to. And we see that there's a big spike for both unhappy and happy customers right in the middle. X4 being I paid a good price, and we see that a lot of the customers are satisfied in general. Even for unhappy customers, most of them are above 3. And X5 being satisfied with my courier. We see that a lot more happy customers over here. And X6 being the app makes ordering easy for me, and again we see a lot more happy customers over here that are satisfied with their user experience. And here's the correlation matrix. No strong correlations between any two variables like I mentioned earlier. So for this project, since the split between happy and unhappy customers is fairly small, instead of focusing on what drives happy customers, decided to focus on what is driving unhappiness for the customers, since there's a large population of unhappy customers. Over here, I used a random seed for data split. This was mainly used during the initial model testing to see consistent results basically over X amount of runs to see if the model is consistent given the seed is changing. And here's the data split over here. Basically X train, Y train, and X validation, Y validation. And I kept it at a size of 25% validation and 75% training. For model selection and preliminary testing, I used lazy predict. Basically did about 20 runs with random seeds like I mentioned, and the top 5 models that performed consistently over the 20 runs are LGBM, XGB, bagging, random trees, and random forest classifiers. And for the following model runs, the focus is on recall and other metrics for unhappy customers specifically, and also considering the overall performance with happy customers as well. The random forest, after 10 runs, these are the metrics. The precision is at 58.3%, recall is at 56.1, and F-score is 0.559. And for extra trees, these are the metrics. Fairly close. Random forest has better recall and precision overall. Here are the metrics for bagging, which is slightly better than extra trees. And here's the metrics for LGBM. As you can see, these are the best performing so far. Upon getting a good model to proceed with for the project, I went ahead with ensemble. The two ensemble techniques that I used for this project are stacking and voting. The purpose is to see if you can improve existing metrics with the model, and if they can perform better rather than just being standalone. For stacking, I basically use the top 3 models, which is LGBM, XGB, and random forest classifiers. And these are the metrics that I got for stacking. Fairly good results, slight improvement over the base model performance. And basically did a different set of models and just to see if different combinations work better. The combination that worked the best is LGBM, extra trees, and cat boost gave me accuracy of 71.875%, which is fairly good considering the dataset is so small. And for unhappy customers, the precision is 0.69, recall is 0.73, and for happy customers, 0.75, 0.71, precision and recall respectively. And I use the logistic regression classifier as the final estimator for the stacking ensemble model. And then I tested the same process with the voting ensemble. And I got better results than stacking when I did voting. As you can see, I got 75% accuracy compared to 71, which was for the highest for stacking. And the best combination that kind of worked for voting is LGBM, XGB, and RF. So far, this is the best performing combination with the voting ensemble. And I used soft voting as it performed better than hard voting for the above models. I tested with random seeds and did about 5 to 10 runs with soft and hard, but soft performed better overall, so I stuck with soft voting. Now that I had a really good base model to kind of work on and get more insights about the data, my goal was to do feature selection if in terms of if I can target more variables that are related to unhappy customers while achieving a similar level of accuracy. So for feature selection, I used recursive feature elimination, a combination of XGB, and the features selected with XGB are X1, X5, and X6. X5 being I'm satisfied with my courier, X6 being the app makes ordering easy for me. And as we can see, there's a really high recall for unhappy customers and adequate precision as well. And like mentioned over here, this set seems to produce the best results in terms of feature selection while not sacrificing the performance heavily. And this basically means unhappy customers, with X1 being my order was delivered on time. They're unhappy, they feel their order was not delivered on time. X5 being they're satisfied with the courier. They're unhappy because they were not satisfied. And similarly for X6, the app makes ordering easy for me. The user experience is not good for the unhappy customers. They don't like the app, or in the sense the app doesn't make it easier for them to order. So these are the 3 target variables that can be improved to drive unhappy customers towards happy customers. And finally, to take a step further, I tried Bayesian optimization, and the purpose is basically to see if you can see further improvements in model performance. And upon doing the Bayesian optimization, I did not see any improvements or any significant results being higher than the previous top performing models. So far, the top performer was the voting ensemble combination with accuracy of 75%. So Bayesian did not perform as well. As we can see, the precision is fairly low. Recall is adequate, but overall results are not any better than the previous runs. So I concluded the project at that, leaving that as the best performing model. And in terms of the features that can be targeted for the logistic company to improve their business model and drive more customer satisfaction. Thank you for watching. You can connect with me on LinkedIn if you have any questions or suggestions. You can also find this repository on GitHub and check it out for yourself as well. Thank you.